Morning. Morning, y'all.
Morning.
Hello.
Morning.
I think I forgot to post that lesson yesterday on YouTube. If these are super simple for you, find KLMN. Find those four pieces. Well, I suppose once you factor it, the coefficients of x are the KL, or the K and the L in any order. And then the MN are the constant terms in the factors. So I guess it's not difficult to do it that way. I'm almost done grading my sixth graders, and then I'll get to your chapter 12 test. Hopefully I can dip into it today. I'll start with period 1, then I'll do 4, 5, and 6 in that order. That's how I usually do it. The good thing is when I do grade it, you don't have to wait till you get the paper in your hand in class. It's immediate. Anybody have any questions for me? Okay. It's gonna be hot today. For those that like to take walks, it's tough to get outside and get your walk in today. Perhaps a drive in an air-conditioned car. Oh wait, you guys don't drive. Pity.
We have our mini electric cars.
You have your what? Oh, your mini lecture car?
We can go down to Target and buy mini electric cars.
You're gonna walk there?
Why not?
They used to call those Power Wheels. And they had a commercial when I was a kid. They'd always market to the kids.
Yeah.
Pow, Power Wheels.
I remember I was like, I think like 3 or 4 years old, and I would go to my grandmother's house, and she had this one, and I would drive around with my little sister. Although I remember just having this massive grin on my face.
Lucky, I always wanted one of those when I was a kid. Never ended up getting one.
That sounds exactly like my story. Because when I was little, I also had one in Canada with my grandmother, and I used to ride with my sister.
Nice. 8:30. Okay, who needs to see number 1? All I need is a yes. No yes?
Yes.
Yeah, all right.
Yes.
All right. Then we'll stop the share. Okay. Sounded like Daniel a little bit there. Hi, Daniel.
Ha ha ha. Hello.
1 times 21. Where'd I get the 21? You ask me, or else I'm not going to tell you. Oh, it's going to be that one. It's going to be there. 1 times negative 21 and 1 plus negative 21. Then you come back here. And it doesn't matter if I use the plus 1x or the minus 21x. It doesn't matter because we learned that when you switch, the m and n and the l and the k are interchangeable. All right, so it won't matter which one you use. So I'll just go in the order that I wrote it the first time. 1x minus 21x minus 3. Notice that you didn't change anything from up above. You just split that into 2. When there's 3 terms, trinomial, you can't factor by grouping unless you could factor something in common with all 3. So when you split it, the middle one into 2, you now have 4 terms, so you can group them into pairs. And then you will be able to factor. Okay, x is the only thing in common here. So you get 7x plus 1 minus, what's in common here is a 3. And then I just copy my 7x plus 1 and check. I like that, it's faster. Instead of trying to look up here and see and get the negatives right, you can make mistakes doing that. Just copy that one over here and check it. Negative 3 times 7, yes. Negative 3 times 1, yes. Checks. So now the 7x plus 1 is in common. The leftover is the x minus 3. K is 7, L is 1, M is 1, N is negative 3. Questions about that one?
Wait, so in this one, instead of having the one that's directly above it being multiplied, it's the one that's directly above it being added in like the
when you say above it, I'm trying to find the it. I don't know what you mean by it. What are you referring to? Above what?
Like the factoring tree, like the 21.
Oh, here. Okay.
Yeah. So
I saw that these are just, I'm just listing factors like when you did in 5th grade, list factors of a number. Then I'm trying to see which ones can I put together to add up to this one.
Okay.
Yeah. This is just a chart that gives me space to list factors.
Oh, I thought that was the 1 and a 20. I didn't see the 21.
Yeah. Other questions? Who needs to see? We'll share screen again. Number 2. Number 3.
Can I see number 2?
Number 2, yep. Okay. So this will be 15. This will be 16. So 1 and 15. Okay, 5z plus 1z plus 15z plus 3. This has a z in common. So you get 5z. 5z is left, 5z plus 1 plus a 3 is in common, 5z plus 1. That checks out. So you get 5z plus 1, z plus 3. I mean, this method is it works quite well. It's not as nice as when you don't have a coefficient, you can go x plus 1, x plus 15 right away. You could skip the grouping. But it's only 2 additional steps is all that you're doing. You're splitting this into those 2, and then you're factoring out what's in common in groups. And then what's left there is what your answer is. Okay? No questions, then I'm gonna go to who needs to see number 3. I really don't want to do them all, but I will if I get a yes. But I really don't want you to draw this lesson out because you just want to draw the lesson out. Only ask if you're really not getting it still. I mean, you're going to get to practice these in your homework, and you could stay for office hours for 5 minutes and ask how to do ones you had trouble with on the homework, rather than this is a lot of practice here see, it's guided practice. I'd rather only guide you for a couple of them instead of just to keep going on and on and on with it. So maybe if you need another one, I'll do one more. 3, 4, 5, or 6. Does anybody need to see one of those? First come, first serve.
3.
Can you
Yeah, I think
possibly do
three.
4?
I just wanna make sure.
Well, what you guys pick, 3 or 4?
3.
Wouldn't 4 be a difference of squares?
No. Difference of squares only has 2 terms. The middle term cancels out when you have a
Oh, that's right.
So whenever you have a trinomial, you can rule out a difference of squares. Well, you know what? I'll do both. I have to remember that I've been doing this a long time, so to me, it just seems like riding a bike. It's really, you don't even think about riding a bike. You just get on. You don't think about, oh, I got to balance it. You just do it. That's kind of what this is. So it's 6 and 1. So it's, let's see.
-2.
No, it's 6 and, yeah, it's 6 and 1. Yeah. So it's 3.
-3 and 2.
You can't do -3 and 2. Because that doesn't give you +6.
That doesn't work because
this
it
is-
doesn't give you.
You can have them both be negative.
Unfactorable.
If you have them both be negative, but that doesn't work either. So this is not
I think it's unfactorable.
factorable.
Is that not factorable or not factorable, Mr. Rosenthal?
It's not factorable.
Oh my.
There.
No questions about that? So if you're listing factors and you've listed all possible factors, this is kind of the way that we did that other challenge problem is there are no factors of this that have a sum of that. So it's not possible to factor. If you were to graph this, you would see it doesn't, it doesn't have, it has roots, it just doesn't have rational roots. Okay?
Mr. Rosenthal, I hate to add, where exactly did you get, like, where exactly is the lesson? Like the online lesson on Schoology?
The lessons in your Zoom lessons folder.
Thanks a lot.
You betcha. Okay, number 4, yes or no? You need to see number 4, right? I need to share that screen. Number 4? No? Okay, number 5?
If possible, could you do 4?
Okay. There's a delay.
Yeah, this happens every time. If you want him to do number 4, tell him to do number 4 as soon
Well,
as he
maybe
has
it's
to do
on a
number
delay. I don't know. Yeah, here we go.
Sorry, I was taking down notes, and so I was a little
Don't
late to
worry.
pressing the
Let's
spacebar.
not get testy here. It's fine. So look, 3 times -12 is -36. Now one factor has to be positive, one has to be negative. Your sum is 5. 1 and 36. I just do the positives first. I just think of it in terms of absolute value. And if something pops out at me, then I'll do it. But these numbers are not close enough. So I just move on. 2 times 18, 3 times 12, 4 times 9. Okay, when I say 4 and 9, I know.
-4 and 9.
There you go. Okay, so then 3x squared minus 4x plus 9x, which is 5x, minus 12. Okay, then x is in common. You get 3x minus 4 here. 3 is in common, so just copy your 3x minus 4 and check. 9x minus 12, yep. Okay, so it's 3x minus 4 is in common. X plus 3 is not in common.
Mr. Rosenthal, is there any way of preventing the screen from switching to the person who's talking? Because every time someone talks, it
You pin
You can
his
pin
video.
that
Pin
person.
a screen.
Touch
Pin
his
the
little
screen.
window up at Pin the the top and hit pin
Like
video.
up in the top,
Okay,
in the
one
top right corner,
person.
there's a blue button. In the top right corner, there's a blue button with 3 dots.
David, he
Click that
gets
and then
it.
click pin video.
David,
Got it.
Oh yeah, I did pin the video. It's still in the work though.
Are you sure you pinned the video?
I pinned the video. Yeah, I'm very sure.
Then it's
Yeah.
not. It's
I
not.
mean, I can
pinned.
try again.
pinning the video means that it's pinning. Pinning means pinning. You're holding it up there so it doesn't come down.
Linus, go to Mr. Rosenthal's video, like go to either gallery view or the other one,
Touch
open it
his
up,
little window.
and then scroll down until you, yeah, and then touch his window in particular, the one that should be outlined in green. And then
No, I'm watching
left
on my
click it,
phone. That's why
and
it's
it
a bit
should
different.
be.
You're on
Oh,
your
it's on
phone?
your
Oh,
phone.
okay.
Yeah.
Yeah.
I
All
mean,
right.
I can watch on my computer.
I would recommend that. Okay, let's get back to this.
Okay.
I can't do the too much tech support now. I mean, that's the answer is pinning. And if it's not working on your platform, then switch to another platform. Okay, 5. All right, 6. Actually, can I see number 5? No, just kidding. 6? Think we get it?
So I'm kind of confused on these little.
Okay, no problem. That's okay. Number 5? I'm waiting for a yes, please, or something like that.
Yes.
Okay. All right, I'm just going to do them all. Ask me questions. Well, I mean, I'm wondering what are you not understanding? Oops. That was like a pause share. That's weird. I hit the pause share. Okay. Okay, here we go. So 4 times the 5 is 20. You should by now know where I'm getting this from. The middle term is the 12. List factors. 2 times 10, 4 times 5. It's the 2 times the 10. 2 plus 10, right? So then you're going to split up this middle term into 2 plus 10. But that is 12. But you're just splitting it that way so you could factor separately. 2u plus 10u plus 5. What's in common here is 2u. Okay, so you get 2u plus 1 when you factor that out of the first 2. Use that sign. Always use that sign. It's a plus. Okay, what's in common with these is 5, and then copy your 2u plus 1 and check it. 5 times 2u is 10u. 5 times 1 is 5.
Mr. Asthal.
What's in, let me finish. 2u plus,
Mr.
let me finish.
Sorry.
Let me finish. What's in common here is the 2u plus 1 times what's not in common is the 2u plus 5. Okay, go ahead, Søren.
Sorry, Mr. Asthal. Just, is this the only subject in this chapter? Factoring.
No, there's
polynomials,
imaginary
or there's
number,
coefficients?
complex numbers. We're gonna have other stuff.
No, not this chapter. Sorry, this section 4.4 is it? Yeah, 4.4.
I don't know. Open up the lesson and look ahead.
All
Okay.
right.
Any questions about this problem? And I'm just gonna go right to the next problem because just to give you that last one, and then you're gonna have to practice them later too. Okay, it's 8 factors of 8 that add up to -9. 1 times 8, it's going to be -1 and -8. Okay, so 4x squared minus 1x minus 8x, that is not minus 9x plus 2. X goes into both, so you get 4x minus 1. Minus, always use that sign. 2 goes into both and copy 4x minus 1. Check it, -8x, yes. +2, yes. Okay, what's in common is the 4x minus 1. What's not in common is the x minus 2.
So I understand like basically how to solve these trinomials, but can you like explain factoring some more?
Sorry? You understand how to factor these polynomials, but then I didn't hear that second part.
I understand how the trinomial, like the
Trinomial, I'm not hearing your question.
Eli, put it in chat. You don't have good enough Wi-Fi.
Sorry, my mic is kind screwed up
You can chat the question if
now.
you like. Go ahead and chat the question. Eli, you're going to have to chat it because I can't hear you.
How it applies.
Eli, we cannot understand you.
Eli, go ahead and chat your question. Just type it in and I'll see it. I'm going to move along, and then when I see your question, I'll stop when I can to answer it. Okay.
Would the roots for this one be 1/4 and 2?
We'll talk about that when we get to that. But yes, it would be 1/4 and 2, yes. It's what makes each one 0. Okay, factoring special products. If the values of A and C are perfect squares, check to see whether you can use one of the special factoring patterns that we already learned about. Okay, so yes.
I'm still kind of confused with the one that's on the board.
Okay.
What happens to like the x and the -2, and like how does it become x minus 2?
Watch this. Go back. How would I go back a step mathematically? You would distribute, right? So you're thinking, oh, 4x times x is 4x squared. 4x times -2 is -8x, which is right here. But I'm skipping 2 steps to do that. 4x, -1 times x is -1x, and -1 times -2 is +2. All right? But why does that work? Okay, now I'm going to show you a weird way to look at it. David had mentioned this. Let 4x minus 1 equal some other variable like u. So wherever you see a 4x minus 1 is unknown, right? And it's a group. Yes or no?
Yes.
Yes or no?
Yes.
Yes. Great. So then if I come down here and I say this 4x minus 1, I'm going to substitute u on some unknown. And now it looks like that. How is that going to factor? It's going to be u
ux minus 2u.
x minus u.
2u.
Okay. Well, that's one step above. Because what is this? This is u, and this is u, right? There's your ux. There's your minus 2u right there. Okay? So if you think about it, this entire group was distributed to the x, 4x minus 1 times the x, and 4x minus 1 times the 2, right? Or the -2. All right? So basically what I'm doing is if I back this up to this step, I'm seeing this as, oh, I see that this is x u times u minus 2 times u. What's in common with these?
U.
The u, but it's really the 4x minus 1. What do you do when you have something in common here? You factor out the u, and then you leave what's left over, and I'm calling the x minus 2 the leftover. What happens to the x minus 2? It comes into a group. See it?
Yes.
Yeah.
So you factored out a 4x minus 1 just like you factored here out a u. You factored out here a 4x minus 1, leaving you the x minus 2 in there. Wait, and if you want to go back, you would just distribute it back to go back. Capiche?
Capiche.
Capuche. You say capuche.
5.
Skadoosh.
That's something different, and I don't like that. No, just kidding.
Understood. I'll say it.
Ben, those are the forbidden words.
Okay.
Bushy finger hole.
Look at that letter A there in example 3. See what you make of that yourself. See if you can find some shortcut to doing that problem.
Well, it looks as though it says next time, so that's the difference. Oh, it's factoring the expression.
Keep that to yourself.
Perhaps they already factored it for you. Oh yeah, they did already factor for you. It's right there.
Well, I'm trying to hide that part, trying to look at it, but you try to do it without looking. Okay?
So much coal here.
What they're hoping you do when you see this problem is notice that everything here are made of squares.
At least they don't have their own coal blocks.
Mute, please.
Somebody is unmuted.
David.
I believe it's
It was
David.
of the David.
Okay, here we go. Here you see perfect squares here, and it's a difference of squares. There's no middle term. I had a student who thought they saw a trinomial and thought it was a difference of squares. It has to be a binomial to be a difference of squares. Here's a binomial.
Because the middle term cancels out.
Middle term will cancel out. So basically what you get is the square root of this plus the square root of that times the square root of this minus the square root. So basically you just take the square root of these. 3x, and the square root of that is 8, and one will be plus and one will be minus.
Yeah.
And you don't have to do any other work. And when you have one plus and one minus, the middle terms cancel out because you get one of them. Hold on. You get one of them to be negative. Hold on. You get one of them to be negative 24x, and in the inside one, you get positive 24x. Those cancel. And then the last term is negative 64, and the first terms give you 9x squared. Okay, so you need a 1 plus and 1 minus in order to cancel out the middle terms to get a binomial.
You wouldn't be taking the square root of negative 64, though. You'd be taking the square root of the positive of the.
You're taking the square root of 64. You're taking the square root of 9x squared. And that is what goes into these slots. Okay, B is not a binomial, it's a trinomial square, or is it? So what are you checking? Go ahead and look at B. I'm gonna write it up here.
So, Mr. Rosenthal, are all of these trinomials or no?
No, the last one was a binomial. Besides the last one?
Besides the difference of squares.
So far today. But there's nothing saying that it has to be. Okay, so you could always go with what we've been doing. Make your chart, multiply, get 100, and do it that way. That's fine. But if you happen to notice, hey, that has a square root that I know. So does that, so does that. The next thing you're gonna do is check your middle term. Your middle term should be 2ab. Remember Pascal's triangle when you have a plus b squared, when you have a perfect square binomial?
That's not a perfect square.
I do want to.
That's not 2ab.
And when you have that, this will be your middle term.
Oh wait, no, it is 2ab.
Okay, so your first term is a squared, your next term is 2ab, your last one is b squared.
That is 2ab.
So you need to know here what a and b are. Well, that's the square root of this. B here is the square root of that.
2a and 5.
Hold on. And you need to double it. And if that's your middle term, then you know it came from that, from a square of a binomial with a and b as the terms. Okay, so you're checking for the 2ab in the middle. So what does that look like? It looks like this. Take the square. If you see perfect squares and you want to save some time, check the square root of that is 2y. The square root of that is 5. Multiply those and double it. So 10y times 2, 20y. If that's your middle term, then it came from that. Notice there's a middle term. It doesn't cancel out because it's not a difference of squares.
Yeah. So you won't have a negative one and a positive one.
Any questions about that?
Wait, so we multiply the square roots. If it's a perfect square, you multiply the roots of the like the n terms.
And double it to see if that's the middle term. If that is the middle term, then you know automatically it factors into the square root of this plus the square root of that quantity squared.
Okay.
I'm going to give you another one to try. 36w squared minus 12w plus 1. Perfect square, perfect square, perfect square. Check the middle term. Now this one has a small difference. You have a minus sign in there. So you should be able to figure out what you do with the minus. Okay, square root of this, 6w. Square root of that is 1. Multiply them to get 6w and double it, 12w. Okay, so yes, it checks out, except it's not going to be plus. In order to get a minus there, that's going to be minus. And you're done.
The equation is minus 2ab.
Yeah, okay, so this term, the middle term, needs to be 2ab, plus or minus, depending on what this is. Okay, if you have a minus b squared, like this is, when you square it, you get a squared minus 2ab plus b squared. That minus makes that a minus, which that is right there.
If A is positive and 2 is positive, so it's negative.
Mr. Ostal, one moment. Could you factor that expression with the regular method?
Sure.
Oh, and sorry, Mr.
Oh, with
Rosen-
regular method, here we go. 36 and minus 12. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. That's going to be negative 6 times negative 6. So you're going to get 36 w squared minus 6w plus 1. Okay, and then 6 is in common, so you get 6w minus 1 minus, only 1 is in common, and then you copy 6w minus 1 and check, negative 6w, positive 1. What's in common is 6w minus 1. What was in common was a 6w, sorry. And then what's not in common was a 6w minus 1. And then you see it's the same one twice, so you can leave it like that, or you can write it like that.
Thank you, Mr. Ostal.
Welcome. Questions? Comments?
No.
Oh, just kidding. Let's see what's next. Okay, so we have a bunch of practice problems that I will put up for you. Maybe I'll give you 2 minutes to try to do it yourself without help. No.
Oh.
That's a copy of what we already did. Here we go.
No, but there's like a line down it. It shifted like a tectonic fault.
Yeah, but okay, but there you go. You have them now. There's your guided practice for example 3. Go. I guess it was, I wanted to go zoom through this because I assumed you guys were strong with this already, strong with the force. But it appears that this was good to
Zoom through this?
I know. I got caught on that yesterday.
Very nice.
Yes. Well, I guess
Ian, you are one of English's greatest intellects.
I guess we are zooming through this every day.
Anyone on the lines?
On the line?
What?
What does that even mean, on the line?
Oh, never mind. Oh, it's just that suddenly
It was so quiet.
I could suddenly hear the silence around me, and I thought my connection had failed, and that's why I couldn't hear anyone.
No, everybody's trying to do the
Of
Problem.
course, that is not true.
that epistemology? Epistemics? How do you know what's true?
Oh, it would be. Well, you would refer to it as epistemology, yes.
Number 7? Yes or no? Number 8? Yes or no?
Yes, please.
Number 8 is 3y plus 2 quantity squared. See it? Square root of the first one, square root of the second one.
But doesn't it, you said it had to be like doubled to get to the second one?
Well, okay, so the first one is 3y. The last term is 2. Those are the square roots. What's 3y times 2?
I did not take the square root of the 4, and I just counted it as a 4.
Right, that's where you went wrong. It's the square root of the a and the c. It's the square root of ay squared and c. You need the square root of y squared also. So you're going to get 3y and 2, and when you multiply them, you get 6y, and then when you double that, you get 12y. So that one checks out, and it's a plus. So it's just 3y plus 2 quantity squared. The next one, let's see, 2r and 7 is 14r.
Wait, so
8. Yes.
how do you check you take the square root of the first term plus the square root of the second term
Times the square root of the
times
third
2?
term. Square root of the first term and the third term. Multiply them and double. 2ab, right? The 2ab. Do you know what I'm talking about when I say 2ab? Or not? Let me know. No, okay.
No.
Okay, check this out. Anything you have there plus any other thing you have there, binomial, when you square it, is a plus b times another a plus b. So you get a squared plus ab plus ab.
And that's 2ab.
That's 2ab. Okay?
Okay.
So whenever you have these two things in there, these are perfect squares. See that? Which is what you're looking at, is two perfect squares. But the middle term needs to be 2 times a times b. But what is a? A is the square root of a squared. What is b? B is the square root of this, right? And you have to have 2 ab's, so you have to double it. Okay, so you're just doing that to check, because you could have a perfect square in the front, a perfect square in the back, and then in the middle it doesn't work, so it won't factor the way you think. So you have to check it.
It doesn't check out.
Yeah. So number 9, you have this 4r squared minus 28r plus 49. Square root of that is 2r. Square root of that is 7. 14r doubled is 28r. So that checks out. You put a minus there and you square it. Done.
For the difference of squares, it's a squared plus 0 minus b squared.
Yeah, but you don't need that.
Mr. Rosenthal, can you share your screen?
Can I what?
Mr. Rosenthal,
Well, you want to see the original problem.
Can you share your screen again? Mm-hmm.
By the way, this is a square of a difference, which is not the same as a difference of squares. I could write a difference of squares.
You just had to confuse them more.
That's a difference of squares. Difference of squares. This is the square of a difference. The square of a difference gives you a trinomial. The difference of squares is a binomial. This is 2r plus 7, 2r minus 7. This is not the same thing as this because of the plus. Hold on one sec, let me finish that thought. This group is not exactly the same as this group. because one is plus and one is minus. So nothing is being squared. The binomial is not being squared. Here, in both of these groups, if you laid it out, they would both be 2r minus 7. So it's exactly the same thing multiplied is that thing squared, which is different than this. This one cancels out the middle term. This one gives you a middle term that's double the square root of the product of the square root of these two. Number 10.
Oh
Yes
yeah.
or no?
Could you say, for additions of squares, could you say a plus or minus b squared?
No. It's not the square of a binomial.
No, you have a plus b times a minus b. Can you say a plus or minus b times a plus or minus b? So then a plus or minus b squared?
No, you can't do that.
That's an interesting new idea in terms of notation, David,
Mm-hmm.
but wrong.
Okay, number 10. Should be 5s minus 8 squared, quantity squared. Number 11 should be 7z plus 3 quantity squared. Number 12 should be 6n minus 3 quantity squared.
No, number 12 would be 6n minus 3, 6n plus 3,
Yeah,
right?
6n
Because
plus
it's a difference.
Oh, it's a difference of squares. Thank you. 6n plus 3 times 6n minus 3. Thank you for catching me there. See what happens when you're just trying to rush through, zoom through.
Trying to zoom through.
All right, I'm going to move on.
Wait, for number 12, it would be
Starting to get bored.
9 times 2n plus 1 times 2n minus 1, right?
Wait, what?
For number 12, instead of 6n minus 3, 6n plus 3, you could say 2n minus 1, 2n plus 1, 9.
Say yours again. 2n. 2n, go ahead.
2n plus 2n 1 quantity.
2n what?
2n plus 1 quantity
Uh-huh. Go on.
times 2n minus 1 quantity times 2n minus 1 quantity times 9.
Okay. So you're saying that this is going to be three of these groups and then a 9? So that's going to be 4n.
No.
I think he meant 2. It's just that it repeated. No, I think he meant 2. I think it was a connection. It caused some repeat.
1 squared minus 1
reverb.
is 9.
I think he meant
it's 12.
only 2.
All right. So if you look, you're right. And the reason is, so this is good. I'm glad you brought it up. Let's look here. Stop this. Okay, when you started with this 36n squared minus 9, these two were factorable regularly because a 9 goes into both. Then you get 4n squared minus 1, which is a difference of squares. So this is 9. This is going to be 2n plus 1, 2n minus 1. And as a matter of
Well,
fact,
you could also, oh, 1 minute. You could also do 9, no wait, oh, that wouldn't work.
the other way of doing it was 6n plus 3, 6n minus 3. But the problem is that's not fully factored because there's a 3 in common here. So when you pull out the 3 here, this one leaves you with 2n plus 1. And when you pull out the 3 here, it leaves you with 2n minus 1. And then the 3 times the 3 make the 9. So this is actually the answer. We didn't get the answer right. This was not the fully factored answer. Everybody see that? There can't be any common factors in the binomial for it to be fully factored. This is the fully factored form. Okay, I want to move on because I feel like this concept is dragging. When factoring an expression, first check to see whether the terms have a common monomial factor, whatever they mean by that. Let me see what they have here. Example 4. Oh, we did that. Okay. It's weird.
Common monomial factor like 9.
Okay, here, factor. Okay. So
Factor of monomial is like 9. Like what I just said.
hold on one sec. Everybody look at A. 5x squared minus 45 is a binomial. And I'm going to stop the share. Okay. If you look here, that's not a perfect square. The 5 is not a perfect square, but they have the 5 as a factor that's in common. So you factor out a 5 to
Turns
reveal
into x squared minus 9.
a perfect square, difference of squares.
5.
Now
X
it's
plus 3. X minus 3.
Not,
put
please.
it in the chat, okay? Put it in the chat.
Trying to listen to Mr. Rosenthal, not you.
The what?
Because just he does this a lot, and it's kind of getting old.
Well, okay, so we'll just remind him, put it in the chat. That's a nice way to do it. We don't want to demean anybody, which in a nice way, we'll say, put it in the chat, okay? Have patience. We have to have patience with one another. Okay, so let me see. Let me move down here. Okay. The next one I'm going to show you. Any questions about this? No? Okay. This can also happen with that trinomial situation. So you can have 6q squared minus 14q plus 8. And you don't see the perfect square, and you don't see the perfect square. So maybe you're going to go right into your normal, which is fine. But what you do notice is that a 2 goes into all of these. So what happens is you remove a 2, okay? And then you have 3
3q squared. Seriously.
minus 7q plus 4. Okay, this is interesting. Now, I mean, let's see. The square root of this one would be root 3q. The square root of that would be 2. So that would not give you that. This is not a perfect square here. All right? So this is not something that you're going to try. If you don't see, I wouldn't try to do this anyway with the square root. So what you would do is you would then factor this part like we were doing, and don't.
-3q and -4q.
I'm going to warn you now that you need to not forget to keep that 2 all along the way. I'm going to tell you as a teacher, having taught this many times, lots of times I see students, the 2 somehow disappears along the way because the student is focused in on this. Okay, so what's this going to be? This is going to be 12 and -7. It's -3 times -4. Okay, so then you have to remember your 2. Some students will say, I'll put the 2 back later, and then they forget. That was me when I was younger. I would forget, so I had to develop the discipline to keep writing it. Okay, so then this is 3q squared minus 3q minus 4q plus 4. Okay, write that 2. Keep writing the 2. It takes a second to write that. It really does. Okay, now you have a 3q in common here. Okay, what's left is q minus 1. Use that sign. Always use that sign. 4 is in common, and I'm going to copy the q minus 1 and check it out. -4 times q, yep. -4 times -1, +4, yep. And now I'm ready to go to my final answer, and the 2 has followed me the whole way, so you don't forget it. Okay, and now I don't need this bracket anymore. I can just say what's in common is q minus 1. What's not in common is 3q minus 4. Okay, that's a slightly more tricky when you.
Could you do number?
What? Any
First, could you do number 13 in the practice problems?
I didn't see a number 13. I don't see a number 13. It looks like it stopped at number 12. What practice problems are you talking?
Under example 4.
Oh, I've only done one of the examples for example 4. Maybe by me doing the other 3 examples, that will answer your question on how to do it. Maybe not.
I'm not sure about this one. Yeah.
Okay, no problem. Any questions about, this is A, example 4A. Any questions about what I did here? The tricky part is when you pull that 2 out in the beginning, you have to factor this, and to make sure you're accurate, I suggest you bring the 2 down along the way, and then the rest of the problem is like what we've been doing before. So the only change here is that. What? Yes, why did I what?
Why don't you redistribute the 2? Why didn't you redistribute the 2?
Because we're factoring it. Because of the instructions, you want to factor it, not expand it.
Okay.
The directions say to factor it, so it tells you that you don't want it multiplied, you want it factored out. Multiplying back is unfactoring it, isn't it? Let's do the next problem. So the next problem is this one. 6q squared minus 14q plus 8. Oh, isn't that the one I just did? Oh, that was B. I'm on C now. I didn't realize that. Okay.
Yes,
So now C is negative 5z squared plus 20z. That's just a binomial. And it has a 5 in common, but you can either take out a negative 5 or a positive 5. So let's say I take out a negative 5, and it's going to be a negative 5z. Just make sure that when you multiply back in here that you get what you started with. This has to be minus in order to get that to be a plus up above. That's it, done. Okay. Any questions about that? That one was pretty straightforward. And then letter D. 12p squared minus 21p plus 3. Okay, I see a 3 in common. So I take out the 3, I put my brackets, 4p squared minus 7p plus 1. Okay, now I see squares. So what is the square root of that one? 2p. Square root of that is 1. 2 times 1 is 2. Doubled is 4. That's not a 4. So that's not going to work. So then I erase that. And then I come back, and I'm going to actually do this. Oh, that's not factorable, is it? 1 times 4 and 2 times 2. Not factorable. So guess what? This is the answer. This is the fully factored form right here.
I hate it when we get a trinomial as one of the factors.
Okay.
Of course, that's always going to happen when you're factoring like a sextonial.
I'm wondering, Søren, if this is what happened to you.
No, Mr. Osthal, I don't think. Could you check number 13? I'm still not sure about it.
Okay, let's
Number
all
13,
start with let's all start with number 13. Why is it repeating what we've already? It's weird. Strange. Oh, I think I know why. Because what I did is I took a picture of the problems without that, and then I took a picture again, which included it again with the next set of things.
Oh, it just must be removed.
I don't remember doing that, but okay. So number 13. Number 13 says 3s squared minus 24. Well, you're going to pull a 3 out, right?
Yes, I just as soon as you started that, I realized it. It just might be that.
3s squared minus 8.
Yes, I know, David.
All right, hold on. So in this problem, you're going to do 3, which is going to come out of both. So you're going to get s squared minus 8.
I believe I realized that just after you started doing it.
By the way, can you factor this?
No.
You can. Watch this.
Oh yeah, 3s plus 2 root 2, s minus 2 root 2, yeah.
irrational factors though. You can factor it if you allow for irrational factors.
You can still factor it. 3 root s plus.
No, you cannot. That's fully factored. Questions about that? Everybody understand the square root of s squared is s. The square root of 8 is 2 root 2. And one is plus and one is minus because it's a difference of squares, right? Except that's not a perfect square, it's just a square. Okay, it's a square of something. Everything's a square of something.
Why can't you factor out 3s?
There's no s over here. You can only factor out what's in common. There's no s over here.
Sorry, didn't see that.
No worries. Okay, you guys take a minute to do the rest of these. 14, 15, 16, 17, and 18. And I'll put them back up on the share screen. I do want to finish this lesson today. See how much more there is here. Oh, yeah, they're preparing you to solve quadratic equations. Wait, we're not going to finish.
I love quadratic equations.
We are not finishing today.
Wait, are we on 4-4 right now?
Yeah,
Yeah, 4-4.
this is a long.
We're
They-
only halfway through.
They should have put solve the equations in a different section.
We're only halfway through.
That's okay. It's really important to master this. So yeah, I would hope that when you go in next year, that this is something that's mastered and maybe you just need a little bit of a refresher. And then you guys will be able to move this. What this will do is help you guys make it that little extra, you know, so that you can really, it's hard to get the pre-calculus so that you're ready to take calculus the following year and pass the AP exam with a 5. It's very difficult to squeeze in advanced math in 9th grade, algebra 2, and pre-calc, and get enough of the way through pre-calc to be ready to start calculus on time. So it all dominoes. And if you have to review a lot of pre-calculus in calculus, what that does is it doesn't allow you to finish the B part. And then you're not ready for the AP Calc exam. So what we're doing now can make that little bit of difference, that 2-chapter difference, but only if you guys are really trying to master this. If you're like, well, it's almost summertime and we're done with it. If you have that attitude, you might be one of the ones that we keep back in Algebra 2 and don't allow you to advance to pre-calc because you're not going to be ready. Okay, so only those who are serious about being ready and keeping forward, moving on, you need to master this. This must be mastered. You must ask me questions and not let me off the hook. You cannot let me off the hook. You must say, no, Mr. Rosenthal, I need to see it. Even if I'm guilting you, which I do, and I don't mean to do it, it's because I want to move on. But me wanting to move on and you needing something, you needing it is more important than me wanting to move on. So you need to stand up for yourself and you need to say something. I don't understand. I need you to go over it again.
So for number 13, you got 3s minus 2 root 2, right?
What I did is I took so I had this. I saw 3 was common. Let me unshare.
And you got 3 open parentheses, s minus 2 square root of 2.
When I took a 3 out, it's s squared minus 8. That's the first thing I got. But I could take the square root of that and I could take the square root of that, and it's a difference of squares when you think about it. So what I could do is a difference of squares is the square root of these plus each other and times the square root of the subtracting one from the other. So I set it up like this: one's plus, one's minus. What goes here is the square root of each of these. So that's s, and this is the square root of 8. What's the square root of 8 is 2 root 2. That's what it ends up being.
You actually have to do that.
Yes. Absolutely.
So it would be wrong if we did 3x squared minus 8.
Yes.
Okay.
All right. You guys can keep working on these, but start sharing which ones you want to see. If you're having trouble, let me know. Say, please do number this. Please do number that. We're gonna end with these, by the way. So don't worry, we're not moving on from here. So feel free to ask me for these.
Can you do number 14?
Yes, I can do it. And even. So 2 goes into all of those. I'm gonna make these the bracket. 4t squared plus 19t minus 5. All right, so then I have negative 20 because I multiplied this times that. 19, 1 and 20 are gonna do it with a negative 1 and a 20. I'm gonna record my 2 every step of the way. Please do that. Please don't dismiss what I'm saying there. You're gonna copy that one and split your 19 into these two. Minus 1t plus 20t minus 5.
Switch them.
Don't need to
4t
switch.
squared goes with 20t.
It doesn't matter. It doesn't matter. Okay, what's in common with the first two is just t. So you're going to get 4t.
And 1.
Always use that.
One.
Hold on, David. Hold on, please. Always use that plus sign, or if it's minus, use whatever that sign is, use that sign. What's in common here is the 5. Copy your 4t minus 1 and check it. 20t, check. Negative 5, check. We're good. What's in common now is the 4t minus 1. Don't forget your 2. I don't need my brackets anymore. What's not in common is the t plus the 5. Done.
$9.29.
So, I mean, if you get this stuff and we reach 9:30, that's fine. But by the way, I do have a watch and I check the time.
I get it. Maybe not other people.
It's so weird. In my backyard, I have a power pole. So, but got it. I was going to tell the students that sometimes they'll just go in your backyard to work on the pole. It's strange to have strangers.
What pole?
There's it's like a telephone pole, but an electric power pole.
But it's not
Oh,
yours.
yeah.
It's the city.
I have it.
It's the cities, yeah. So that
So they
there's
just come into your house.
no. My wife just said they asked permission to come, but if we were not home, they would go back there to the backyard, and then yeah. Anyway.
How would they get to the back?
You guys, we can do the rest of these. I'm not going to come back to these. So I want to be careful when if I say dismissed, I'm not coming back to these problems. So I don't want you to think that class is over and then I need to show you these again. You have to stay for office hours to see the rest of these. And then we're going to move on. So
Or you just watch a recording.
If you totally get this, you can go. Okay, if not, watch the participants now. Yep, there they go. There they go. I see you going. They're leaving. Yes. But now I'll stay to do the
The
rest.
numbers are dropping exponentially.
No, not exponentially.
12 of them.
Linearly.
You don't know that. You're not counting the rate at which they're
Good
dropping.
point. Good point, but it's not exponentially.
You don't
Thanks
know
all
that.
for the lecture, Mr. Rosenthal.
Okay, so moving on. Let me know what other ones you would like to see now.
All
Mr.
of them.
Mr. Osta,
Yes.
just one question. When you said we would have to prove the product rule in calculus, are we going to use the binomial theorem?
Ducks.
I believe that you do use the binomial theorem,
Oh, that's too bad.
but I don't remember in which proof you do that in. I don't remember if you use that in the power rule. Earlier this year, I proved all the rules. They were not difficult to do, but it's like those proofs in geometry where you need an auxiliary segment. You have to be told this is what you're going to, how you're
I
going to.
hate auxiliary segment.
Specific,
Well,
a
it's like,
specific trick, yeah.
Here's how you need to set it up, and here's a trick. And then once you learn the trick, you realize, oh, I see why that works. I totally get it. And then when you're away from it for a long time, it's really easy. I forgot how to start all of them. Because if you don't set it up a specific way, you can't just do it.
Oh, also, it's because, Mr. Rosdahl, I read a proof of the power rule using the binomial theorem, and that was kind of a spoiler. I wanted to learn it myself.
Good.
But did you prove the trigonometric identities too? The derivative of sine x equals cosine x?
Yes.
Oh, okay. Thank you, Mr. Rosdahl. Have a good day. See you tomorrow.
You bet. All right, I'm staying. So somebody asked for all of them. Let's do all of them. 3 is in common.
Daniel asked for all of them.
Pull the 3 out. You get 2.
I was joking.
He was joking. He's like, all of them. He's
Does
joking.
anybody want me to continue with this problem? Say yes if you do.
Sure, last one.
Okay. So I saw 3 was in common. Okay. And then 2 times 5 is 10 with an 8. So that's, not factorable, right? 1 times 10 and 2 times 5, you're not going to get an 8. So you're done. Ha-ha, that's what you get. No, just kidding. All right, anybody want to see any others?
Do you really get something?
Yeah,
What?
he got a short answer instead of a long.
Yay.
Anybody else?
I hate short answer questions.
Anybody have any questions about anything?
No.
Meaning of life?
42.
Yes, let's say
42. The question is 9 times 6.
You're going through a phase. The phase that you're going through is the Douglas Adams, the meaning of life is 42 answer. But I've heard it too many times to keep saying that. So that phase is over in my life. I don't say 42 to that answer anymore, or to that question.
9 times 6.
9 times 6 is not 42.
I know, but that's the question.
Oh. Well, to that, if you said 6 times 7, then I would answer 42.
I know.
But to the question, what is the meaning of life, I no longer answer 42. By the way, it was wrong. If you read the book.
I didn't read the book.
When the computer came up
Hey,
with,
I didn't read the book.
Oh, are you going to?
Yes.
Okay, read the book. You'll enjoy the book. For you, you're going to love that book.
Wait, what is it called?
The Hitchhiker's Guide.
Hitchhiker's Guide to the Galaxy.
Oh.
Yeah, it's a great book. I mean, the satire, the guy, Douglas Adams, is sharp. What he tapped into was really clever. Just really witty. If stuff will go over your head if you're not paying attention.
Interessanto.
Yeah. Hitchhiker's Guide to the Galaxy. The Vogons. You're going to learn about the Vogons. Any other questions?
0.
What about covestance? Do you guys see the power pole, guys?
The what?
Oh, I shouldn't.
Oh, yeah, the power pole.